Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at the types of IPv4 access control lists. We'll be discussing standard and extended access control lists, numbered and named access control lists, where to place those ACLs, and then specifically, we're going to look at standard and extended ACL placement. This episode is part of my series on enterprise networking, security, and automation. I'm Kevin here at KevTechify. Let's get this adventure started. As a refresh, there are two types of access control lists you can have. You can have standard ACLs and you can have extended ACLs. The standard ACLs are the simplest, but they do the least when you're looking at the control of it. The standard ACL, it can either permit or deny. So you have to choose either I'm going to permit traffic through or I'm going to deny it. And then it's only based upon the source IPv4 address, where that data came from. That's all it's based on. It's not based on where it's going, the destination. It's not based upon any layer 4 information, that layer 4 logical port number, TCP, UDP ports. It's not based upon any of that. Then we have our standard ACLs. Once again, it's permit or deny, but then we can get into finer granular control. We can look at both the source and destination IPv4 addresses. We can look at the protocol types. And by protocol types, what we're looking at here is those layer 4 ports. And as a refresher, port 80 is HTTP. And then we can also look at source and destination TCP and UDP ports. A lot of different settings we can filter on to give us that finer granular control of our access control entries. When we start creating your access control list, you have to give it a number, a way to identify it. And in our previous examples, that's where we had access list 10. And all of our access control entries went into access list 10. Based upon that number, it can either be a standard access control list, it can be an extended access control list. And then there's a couple other types of access control lists, which are a little bit more complicated. But if you come in here in global configuration mode and type in access list and then put a question mark here at the end, a space question mark, it'll list out what the ranges are. If your access list has a number between 1 and 99, you are looking at a standard access list. And once again, that's just looking at the source IP address. If your access list is a number between 100 and 199, you are an extended access control list. That's source, destination, IP address. That's that layer 4 port number, source, destination, TCP, UDP ports. You can go in and look on that. We can also look at MAC addresses, which once again is a little bit more complicated. Then we come down here, and then if it falls in the range of 1300 to 1999, these are standard access control lists again. Now, why did we go ahead and do that? There's been some situations where having 1 to 99 access control lists aren't enough. And so they had to give us a bigger space to have more access control lists. Right in here, this gives us almost 700 more access control lists we can create. Each one of those control lists has all their access entries. But remember, each interface has an inbound, outbound IP address, access control list. If you have 100 routers on your network, you may run out of access lists fairly quickly. That's why we had to expand a little bit more. We can also see here 2000 to 2699, another 700. These are extended access control lists also. That allows you to look at that information. So this is where we can go ahead and find out where our information is regarding what the number is and what it relates to, standard or extended access control lists. Not only can you number your access control list, you can give it a name. Instead of calling it access control list 10, what you can do is give it a name. And maybe that access control list 10 that was stopping Telnet from coming in from the internet, we'll call it the Telnet filter. A lot of people say naming your ACL is the preferred method of setting up your ACLs. A lot easier to remember. You can have both standard and extended be named. And then the other thing is your name, it can tell you about what that access control list does, which makes it a little bit easier to remember that access control list 10. You have to remember what that 10 is doing, or if you're calling it Telnet filter. And if it's Telnet filter, oh yeah, we're filtering out Telnet. It's just a nice little cue there to let you know what's happening. When we go ahead and create this access control list, we start off with IP access list. Now, instead of putting a number in here, because that number, once again, if it was 1 to 99, that was standard. And then 100 to 199, that was extended. Because we're not using those numbers here, we actually have to tell the router, is this a extended or extended or standard ACLs? And then once we tell it that, then we can give it the name. That name is case sensitive. So when you go back to refer to those ACLs, make sure you remember that is case sensitive. If you like this episode on the types of IPv4 access control lists and you get value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, subscribe to my channel, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Because an ACL can be placed on any router, any interface on that router, you should place those access control lists where they're going to have the greatest impact on efficiency. Now, what that means here is an extended ACL should be placed closest to the source. An extended ACL should be placed as close to that source where that data is coming from as possible. Then the standard ACL should be placed as close to the destination as possible. There are also some factors that influence where that ACL is playing. First one is whether or not the organization has control of both the source and destination networks. If you control both the source and destination, then you can pretty much pick where you want to put it. But if you control only one side or the other, then you have to put it on that end you can control. If you have a lot of bandwidth consuming traffic on your network, you may want to put an ACL as close to that source as possible. Putting it as close to that source as possible would eliminate as much of that traffic as you can. And then we would also look at ease of configuration. It might be easier to implement an ACL at the destination, but the traffic has to travel all the way through your network until the destination. If you really wanted to do it right, that extended ACL would have to be placed on each router where that traffic originated. It would have to be placed on that router where each one. So if you have traffic originating on different routers, you'd have to recreate that access control list multiple times on each one of those routers. And so how easy is it to configure your network? Most of the time, at least in my opinion and most people's, that ease of configuration isn't necessarily a factor, because you want to optimize your network. Even if it takes you longer to configure it and set it up, you want your network to be optimized in the long run. We talked about the standard ACL should be placed as close to the destination as possible. When we say as close to the destination, we mean that last router in the journey to get to its destination. In this example, what's going to happen is PC1 is sending data here to PC3. So it's going from 1 to 3. What we want to do is stop that traffic from actually happening. And right here is our statement that we probably worked with maybe management that we want to block all traffic from the 192.168.10.0 network to the 192.168.30.0 network. And maybe this is engineering going to, so engineering here to HR. We don't want the engineering people in there to see any of the personnel records. And so we want to block that traffic. We're going to use a standard ACL. That standard ACL looks at that source address. Now, the reason we say place it at the device closest to the destination, so we'd want to place it on R3 here, is when traffic comes out from our network, we want to make sure it can reach the rest of our network. Maybe PC1 wants to go to PC2. Maybe PC1 has to go to PC4 at some point in time. We want to make sure that that traffic can get all the way up from PC1 to switch 1 to R1 to R2 to R3 all the way over to R4. Couple ways to do this. Now, the first big clean sweep, let's just block all traffic, is you could put a filter. And now how these filters look, these pictures, notice the wide end is here, the small end is here. What this means is we take everything in here. So all traffic comes in here. We only permit out certain stuff. So we block off certain types of traffic. So we come in with a lot of traffic. We go out with just what we want. And so the traffic is going this way through the graphic. It's going from left to right, going from router 2 to router 3. If we just say, let's go ahead and block everything on the 192.168.10.0/24 network, so based on the 3 octets, we're going to block all traffic here from both the 192.168.10 network and the 192.168.11 network. That's not what we want here. Instead of creating this inbound ACL on serial 011, we create an outbound ACL here on G000. So all traffic that makes it out here, because we may have traffic that legitimately needs to get down to PC4 here, down to this network. We don't want to block that, but we do want to block this because this is our statement up here in this yellow box. Block all traffic from the .10 network to the .30. And what we do here is this interface is on the .30 network. We're going to put our filter here. Once again, our filter is filtering traffic going this way. And we're going to create an access control list that says this. We're going to block all traffic that originated over here on our .10 network that is going to the .30. And so this applies, this meets what our requirement is when we started it. So that source, we're looking at the source, where it came from, which is our .10 network. So we're going to block all traffic from the .10 network. And because this interface is on the .30 network, and only the .30, we're only blocking traffic to that network. So the standard ACL places close to the destination as possible. When we place an extended ACL, we want to place it as close to the source as possible. In this example, PC2, we're looking at the traffic from PC2 to PC3. And specifically, what we want to do is block FTP and Telnet. And so looking at that, we want to create our access control list here on R1. But the question is where do we want to put it? Do we want to put it on the exit of serial 010, or do we want to put it on the ingress of G001? If we put it on the outbound traffic out of serial 010, it's going to look at all traffic from any other network connected to it. So it's going to look at traffic from the 192.168.10.0 network and the traffic from the network we're trying to stop. So it's going to examine all that traffic. And it also has to go through any routing we have set up here. Whatever routing we have, the steps in our routing table, we have to go through and match that and process that. And so that takes computational power. That takes memory to do that. And then we have to filter all traffic here. The better spot to put it is the inbound traffic here on gig 001. When you put it on this interface right here, gig 001, we're only going to look at traffic from the 192.168.11 network. We're not going to look at traffic from 192.168.10. We're not concerned about it. Our access control entry, we're not worried about that. We're worried about traffic from our .11 network. And putting on the inbound interface right here of G001 does that. And when we do that, the router doesn't have to process that at all. So that takes less computational power. Our router will be overall more efficient. It was my pleasure to bring you this wonderful episode on the types of IPv4 access controllers. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. You can get all these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation. In the bottom right is one of my favorite videos that I picked just for you. Thank you so much for watching this episode of my series on enterprise networking, security, and automation. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.